Hello, everybody. Welcome to the webinar. If somebody could just put a message in the chat just to let us know that you can hear us okay, that would be great. And we'll just, thanks, Derek, and we'll just wait a couple of minutes for any stragglers. What is it, 4:01? So just wait a minute or two. Got Jeff with me here.
Hi, everybody.
This is Jeff's first time in a webinar. I'm hoping that having Jeff here is going to make this a little bit less death by PowerPoint, and that we'll have, you know, a bit of rapport or something. But it's Jeff's first time doing a presentation, so, you know, don't be afraid to be a robot. Because it always feels easy until you actually do one, and then it's you know, at least for me, it's harder than you think it's going to be. So what are we, 4:02? Just wait a few more minutes. But basically what we're going to cover today is commissioning of a Deye inverter, and with a bit of a focus on just commissioning problems that people tend to have, that we tend to see and get calls about, and focus on the various different types of managed batteries that you're going to connect to these inverters and how that might cause issues when you're trying to get it all working, and what the quick fixes are for that. If anybody's got anything in particular they want us to cover, please let us know in the chat. So we will go through some really basic stuff about the physical setup of the inverter, but we're going to assume that you can all sort of read the manual and do that stuff. So we're going to focus more on the software side of things, or the commissioning side of things, and we're going to focus mainly on the stuff that we think is counterintuitive. We can't go through absolutely everything because we won't have time. Can you confirm there is no difference between old NOARC version and the Deye? Yeah, the only difference is that because the only difference would be that there are firmware updates to the newer Deyes, which might have some different menu options. But a NOARC is a Deye, and the NOARC inverters get the same firmware updates as the Deye. So if you've got a NOARC out in the field, you can update the firmware if there's something you've seen on the Deye that you haven't got on that particular model. But the particular different sizes have different features and things as well, as I'll show you. Lachlan, batteries overcharging, I'll come to that. There's a few things to talk about with some of the overcharging issues that we've seen. So we'll start now. We're 5 minutes in. So we'll kick this off. So, you know, the main features of these, obviously they're hybrid inverters. They're an all-in-one, which makes them nice and quick and easy to set up. And you can use them with managed and unmanaged batteries. They've got a great portal. The portal gets better all the time, actually. You can use them for parallel. You can use them for three-phase. They're either with a three-phase model or by using 3 single-phase inverters set up as three-phase. You can also do split-phase as well. And we've got plenty of people using these off-grid now as well, and they're popular for that. So, like I said, we're not going to go into the physical setup of it too much. It has all the standard stuff you'd see in the box. There's no particular gotchas with that. The wiring of it is reasonably straightforward. Here's a basic setup using some Discover rack mount batteries. But the stuff that I'll want to focus on with this is things like the BMS wiring, and just some of the gotchas. So if you're doing managed batteries with these, assuming you've got your inverter, you've got it on the wall, and that's all gone fine. You've connected all your PV. It has a built-in PV isolator, so you don't need an external PV isolator. You've got it up on the wall. You've wired in the positive and negative of the batteries, and then you're wanting to connect the comms. So the comms have an RJ45 plug on them. This will be in a slightly different place on different models, and this will be in the manual. And that is an RJ45 cable, and that's going to go down to your managed battery, such as your Discover or your Pylontech. These are mostly a straight through cable. And what I mean by that is it's not a crossover cable like you might see with Selectronic or Victron, where it's going to be on pins 1 and 2 at the inverter end and 4 and 5 on the battery end. They're mostly going to be a straight through cable, which makes things easier. So you can use a standard RJ45 cable. But if you look in the top left-hand corner here, this is the pinout for one of the Deye models, battery comms. And you can see that the CAN bus is on 4 and 5, which is the standard. And that's what Discover used for their CAN bus, and that's what Pylontech used for their CAN bus. But you can see that the other pins are taken up with RS485. Specifically on pin 6, we've got ground as RS485. So if you connect the ground from the CAN bus to these ports, sometimes that will mean it doesn't work. Not all of the Deye models have this configuration. Some of them just have a CAN bus RJ45 plug, and it only has CAN bus on it and doesn't use the rest of the pins for anything else. And so you can just use an off-the-shelf cable. But some of the time, some of the models have this setup. So I'd recommend you just run the CAN high and low, so pins 4 and 5, and skip the other ones. And check the manual to see if it applies for whichever inverter you're using. But that's a really easy gotcha, that you've wired everything up and you think everything's right, and then it doesn't work because of this. In terms of the comms wiring for single phase and 3-phase, there's just parallel connections which are going to run between the inverters when you're connecting them more than one. And as you can see here, there's the BMS port, and you've got the parallel ports. Each model is slightly different, so you'll need to check the manuals for that. But that's the only thing you're going to need to use these RJ45 ports for when you're wiring all up, unless you're in Queensland and you're using DRM, in which case you'll know about that. In terms of the PV connections, again, this is reasonably straightforward. On the smaller modules, the MPPT voltage range is quite low, 425. So you've got to make sure you don't exceed that. But the rest of it's pretty straightforward. The CT and the meter wiring. So these inverters come with 2 options. It comes with a CT, which you can hardwire directly into the inverter, or you can not use the CT and you can use a meter. So the purpose of the CT or the meter is to monitoring the input current from the grid, or from a generator if you're doing it off grid. So that's so that you can see what's at the main switchboard if you're doing an on-grid connection. You can use either the CT or the meter, and they both perform the same function. The CT can be extended. It comes with a length of cable which is quite long. I think maybe it's 10 meters or something like that. But I've heard of quite a few installers now who have run Cat6 cable from the inverter to the main switchboard, like 20, 30 meters, and then they've just spliced the CT onto the end of that and put it at the main switchboard instead of running a meter, and it's worked fine. So you don't have to use the meter if you're a long distance away. You can extend the CTs, and that works perfectly fine, and it's slightly simpler. The you can see we've got the inputs for the CT here in the diagram, and so it's just these push-in style connectors, the third and the fourth on this particular model. What's really easy to do is to get the CT the wrong way around, and that goes for when you're using the meter as well. Gary says he's got some running up to 100 meters. There you go. I'd recommend you probably use a few pairs if you're going to go that far, just so you don't have too much resistance, even though the current is really low. But it's really easy to get the CT the wrong way around. So I recommend that when you set up one of these systems, once everything's working, go and put the kettle on, or put some large load on, and check that the direction makes sense with the load that you've got on, because it's really easy to have it the wrong way around, and it means that a bunch of the other functionality, which I'm going to take you through in a moment, won't work properly. I actually had a family friend of mine recently who had a system installed by somebody I don't know, and they'd had it installed for about a year or something, and it just wasn't working properly, and eventually they got me to come and have a look at it, and it was trying to export all of the time and running flat out all of the time. It's because the CT was run the wrong way. So it thought that it was exporting when it was actually importing, and it just messes all the logic up. So that's a really easy mistake to make. The other one that I've seen is if you're doing a three-phase job, is to have the wrong CTs on the wrong phases as well. So again, it seems like an obvious thing, but it's a really good idea that when you finish doing everything else, to just go and check each phase and check that the current lines up, put a load on each phase individually, and check that it all lines up and makes sense before you leave, because it might save you one or many trips back to site before you figure out that's what's happened. Oh, Gary says he uses all the conductors when he extends it with a Cat6. Okay. If you're using the meter, then you're going to use one of these RJ45 plugs on the inverter, and you're going to run that and run the meter to the main switchboard most of the time. And there's a few gotchas with that, and I've got a little diagram a bit later on to show you what to be wary of with using the meter. I've had people looking at the settings and things like that. I haven't seen any so far that haven't had the settings correct right out of the box, so you shouldn't have to adjust the baud rate and things like that. I have had somebody get a different size CT and then have to change the CT ratio on the meter after the fact, and that was a bit of a headache for them. So I'd recommend not doing that unless you really have to, but it can be done. And so here's just an example of a three-phase. If you're using the CTs in a three-phase Deye rather than using a meter, then you've got 3 CTs which you're going to use with these push-in connectors over here. And so it's really important to make sure that you get that wired correctly.
Is it recording?
I don't know.
Oh.
It usually is.
Okay. Oh, sorry. Right.
So I'll skip through this because I've got some better slides on this aspect of things. I'll skip through the chassis earth. In Queensland, if you're using the DRM, then you'll know about that, and it's just a little plug that you plug in to the DRM port. Again, it will be slightly different on each model inverter, but it shouldn't be too difficult to find. So for the meter, most of you will be using the single-phase meter. The three-phase meter is basically the same. So there's a few things to be wary of with the meter. Obviously, you've got to power the meter, and so we've got neutral and active up the top here in ports 3 and 4. I'd recommend that you actually put your wires into that before you put it on the DIN rail in the main switchboard, because it's quite fiddly and the screws are a bit funny. and it can be a real pain once it's all in there with all the rest of the mess. So I'd recommend that you put that in the top first and then put the meter in place. You need to put a fuse on the active. People use these little inline ones from JCar sometimes. You might want to put some heat shrink around that to make sure it's rated to 240, or you could just use a circuit breaker if you had enough poles. Don't wire the active and the neutral into the bottom instead of the top, because that will blow it up, which is I did in the workshop the other day. Down the bottom here, we've got 1 and 2, which is where the CT is wired into. That's pretty straightforward. The main thing to know about this is that if you do put the meter facing the wrong direction, then you don't have to get up to where you put the meter to change it around. You can just swap these 2 cables around to flip the direction. Pins 5, 6, and 7 here, these are pulse width modulation outputs, which you won't be using, so you don't need to worry about those. But then we've got pins 8, 9, and 10 here, and that's what we're going to use to go back to the inverter with our Cat5 cable. And so there's 2 gotchas with this, really. One is it's really easy to get the A and the B the wrong way around in terms of marrying that up, what goes up the other end of your RJ45 cable. And the other is that it's got the same issue as I showed you with the BMS, which is that sometimes connecting the ground means that it doesn't work because they're using the ground pin for something else, and it confuses everything. So I'd recommend not using the ground most of the time. What I'd recommend you do, because people quite often find the meters needs a bit of troubleshooting, put your meter in place, fire it up, and then get your multimeter and measure the voltage output on A and B. And you should get, I think it's 3 volts or something like that. And then down the other end, at the end of your cable, measure it there as well, and make sure that your A and B are the right way around. And if you've got voltage there, then you know that it should be talking to the inverter. It's just a quick thing to do to make sure that you haven't actually got a problem in your connections in between the 2 before you start having trouble with the actual software commissioning of things. So here's an example. This is from 4 different Deye inverters. And you can see that the meter port is slightly different on all of them. The one in the top, the one in the bottom left here, you can see the meter is just on pins 4 and 5. And so it's perfectly, there's nothing else for the ground to go to. So it wouldn't matter if you connected the ground. But on these other ones, so the one in the top right-hand corner, you've got RS485 on some of these other pins. So I'd recommend just not connecting that ground. I don't think on any of them it even requests it. Does that make sense to everybody? I know it's a bit counterintuitive, but unless you've got some interference or something, you shouldn't need it. Have you seen any other meter-related troubleshooting issues?
I think you have covered most of it. Yeah, just that I have the error point in the wrong way.
Yeah.
And I have connected to the different phase.
Yeah.
And it sort of mess all around in readings and but that's pretty much it.
Yeah. And if you get the arrow the wrong way around, you can just swap those 2 wires, and that goes for the CT or for the meter as well. So then we want to get the Wi-Fi connection happening. You don't have to do this before you do the other commissioning steps, but we'll cover it first. I highly recommend that if you are installing a Deye for the first time, then you go and make an account on the Deye cloud before you go to site. Download the app on your phone before you go to site and get familiar with it. It's pretty easy to make an account on the cloud. This webinar software I've got doesn't use my slides properly, so they're all sitting on top of each other. So I was going to show you what you need to do there. Basically, when you go to the Deye website to create an account, it's going to give you a few options that you'll need to navigate. You want to select that you're an installer. It will ask you what server you want to use, and I think it recommends one for Asia Pacific, which I think is the European server. And then you just put all your information in. It's pretty straightforward, but it's a really good idea to do that before you go to site. Download the app on your phone. It's available on Android and on Apple. And this is what the little icon looks like. And the platform and the app gets better and better as time goes on. They're always adding features, and there's some quite exciting stuff coming up. They're not available yet, but there's going to be wireless meters available using Zigbee, I think, and all sorts of wireless smart power points and things that will integrate with the Deye systems. So I've got some questions here. When installing on-grid, need the meter, but when off-grid, you probably don't need a meter for off-grid, but you'd use the CT because you want to measure the incoming current of the generator. Lachlan, do units need Wi-Fi all the time or only to set up and commission? No, they don't need Wi-Fi for an ongoing basis, not like the Whispers do. So you don't need to set up the Wi-Fi at all if you don't want to, but it's a good idea because the monitoring is really quite good. You can do firmware updates remotely, and obviously here at Tech Support we can help you remotely with it, and it makes a big difference. But yeah, it's not required for it to function. Okay, Jeff is going to present how to set up the Wi-Fi connection.
Hi guys. So to set up is actually quite straightforward. Once you got the dongle plugged in, you'll see the ready light that's flashing. It means it's ready to be configured. And basically, you just need to create your plan, and then you connect to the Wi-Fi, and you wait for 10 minutes, and that's pretty much it. So here's the first step to create the plan. On your Deye app, just log into it, and then you can create a plan and share it with your clients later on. And to do that, you go onto the top right corner on the left-hand side of the photo. You create a plan and you fill out all the information where this site is, and
do you have to do this before you join it to the user's Wi-Fi? Do you have to? Does it matter which way around you do it?
No, I don't think so. You can just log the Wi-Fi, but I'll just do it step by step because I'm assuming that you'll probably just do it for the first time and got everything wired up. Yeah, you fill in all the information where the plan is and what the system type is, and also if it is an off-grid or is an on-grid system, and then the total capacity of your panels. And then that's finished. That you got your plan created in your app, and then next is to get your logger connected to Wi-Fi. And so this is in your plan. You click on your plan, and on the bottom right corner, you select the overview, and then go on to the top right corner and click on add a logger. And it pops up a QR code scanner. You can just scan it. There's a little QR code over there.
That's what the new one looks like, and the older one looks like that. It has a much smaller QR code on it. But the newer ones, these big ones with USB.
Yeah, once you scan that, it will just add that in, or you can manually add it up, add all the add the logger into the app. It's got all the information on it. You will have the serial number, the password, and you can just put it up into the app, and then it will be connected. Next is just to get the Wi-Fi connected. you go onto the device and you click on Wi-Fi configuration, and then just select whatever Wi-Fi you're having on site, and you just put up the password. Then once you put up the password, you will pop this up where you have to connect this logger to your mobile. You click on the connect, you jump to the your Wi-Fi configuration, and you need to connect to the AP, whatever serial number you're having, and then with the password. This password is on the logger itself. You got all the data on the sticker.
So that one there, is it?
Yep. Yeah. You just put that in. And
so the app is going to prompt you to join your phone to the hotspot of the logger. Is that right?
Yeah.
Yeah. Okay.
And then you'll see that your Wi-Fi is your phone is connected to the logger, and that's pretty much it. Then you'll start run all the configuration, and in the end of it, remember you need to wait for 10 minutes for commissioning. So you can just leave it there for 10 minutes.
So it's 10 minutes for it to, do you need to leave your phone there, or
no,
just 10 minutes before it's going to show up on the portal?
Yeah, it's just 10 minutes. Then on this small little red box, if it's within 10 minutes, if it's just finished commissioning, then it will show an orange light saying it's commissioning. But after 10 minutes, it'll be showing like that. It's online. Okay. And that's pretty much it. Right, that's everything you need to do for setting
cool.
up Wi-Fi.
Thanks, Jeff. Okay. Something I noticed when I was doing one for helping somebody with one the other day was that when you create an account, it will give you a really wacky identification name. Even though you'll put your username in, it will come up with this other really wacky name that will be displayed in various places, including when you share the system with somebody else. And so if you go into your personal details, up the top left-hand side here, the picture of a person, if you go and edit your profile, you can change that name because it's a bunch of numbers or something, and it looks really dodgy. And I didn't realize it until I was helping somebody with their system the other day, and I changed mine to DPA support or something like that. So that's just something to be aware of. If you have trouble using your phone to connect with the steps that Jeff just outlined, there is a workaround where you can use your laptop to connect to the hotspot of the Wi-Fi dongle as well. So you can just connect to it as you normally would connect to any other Wi-Fi hotspot, and then go to its IP address if you get stuck and your phone doesn't work. I think that will only happen if you've got a really old phone or something like that. We used to see it happen with the Noark dongles. I haven't seen it happen with the Deye ones so far. But if you do get stuck like that, you can give us a call and we'll help you do it the long way around, but it shouldn't be a problem. Once you've set up Wi-Fi, you might need to set up CSIP as well. So CSIP is the inverter, the dongle, talking to the electricity network so that they can use the backstop to ramp the inverter up and down, well, down, if they want to. If you don't have CSIP happening, then you have to export limit the inverter to 500 watts for most DNSPs. Lots of people I speak to seem to not bother with this because the feed-in tariff is worth so little, but there are some instances where you might want to take advantage of some of these VPP plans that are available now. Not so much Amber, but things like the Glowbird one, when you can get paid quite well to export your battery power between 6 and 8. And so you'd need to have CSIP set up if you wanted to take advantage of that in a meaningful way. So the way to do that is reasonably straightforward. You'll need to make sure that you have the latest firmware version, but I think all the inverters that are shipping now have this firmware version. And then once you've once you've checked the firmware version, you're going to go into plant info, and then you're going to go down to edit information. We've got the bottom left-hand, bottom center, I should say, just the bottom right of my slide. And then you'll have this option up the top here, utility connection registration. If you don't see this, it will be because when you set up your account, you set it up as a personal user and not as an installer. So when you set up your Deye account, it's really important to get that right. But I think you can change it. There's this thing called switch perspective that you can change it, I think. But you click on that, and then it's going to ask you questions about the what utility you're with, the serial number, and the NMI. And then it's going to generate an LFDI number for you. And then once you've got that LFDI number, it's going to be, write it down or copy it or whatever you want to do, but you'll be able to go and get it again later from the cloud if you lose it. But you then use that to do the CSIP registration process with whichever DNSP you're operating with. Does anybody have any questions about that? It's reasonably straightforward. It's just navigating these little menus in the app. It can be a bit confusing. And there's a document on how to do it, and that's on our tech support portal. So we'll get into the programming. I'm actually going to share my screen because I know that my slides are not working properly. So just give me a moment. Okay, so this is what the main interface of the Deye inverter looks like. And you can see we've got 4 icons here. We've got PV in the top left-hand corner. We've got the grid in the top right. We've got loads in the bottom right, and we've got batteries. There's a new feature which I haven't got on the slide, which is which will be in the center here below the on icon, which is another load. And I think it says UPS, doesn't it?
Yeah.
And that allows you to see where your grid loads are and where your backup loads are. But we're mainly interested in these bits here. You can click on each of these to get information. So if we click on the PV one, we'll see the voltage and the current of the array. So you can check that you've got DC coming in from your array. If you click on the grid, then you can see the voltage of the grid, and you can see what your CT is measuring as well. So that's an important one for checking that your CTs are working how you think they should be. And it's got some total stats and things there as well. The bottom right-hand corner here, we've got the load. And so that's going to show you, how much power is going out to the load. This is, what's interesting about this is that the Deye inverters, kind of unlike maybe Victron and Selectronic, is that they just take a bit of time to do anything, which makes troubleshooting a little bit annoying, because you make a change and then you have to sort of wait a minute or two for it sort of to make any kind of change. And so often people will say, oh, I've set up the system and the loads are not on. And it might be just sort of waiting. And if you click down onto the load terminal, you'll see the load voltage here, and that will build up until it gets to 230, and then it will engage. So if the load terminal isn't turning on, if you click on there and you see it slowly rising, then chances are it's going to turn on in a minute or so. But if you see that and the voltage is just 0 and it's just not moving, then you've got a problem somewhere else. And then the last one over here is the battery. This is quite important for our purposes today. because this is where we're seeing the state of charge of the battery, the voltage and the current. But more importantly, if you're doing a managed battery, which most of you will be, if you click in the bottom right-hand corner here, you will have Li BMS. When you click that, you're going to see this screen here. And this screen is showing the actual information that's coming from the CAN bus out of the battery. So just for those of you who don't know this, the way that the interaction between the battery and the inverter works is it's pretty much a one-way street, in that the battery is just sending information to the inverter. It's sending it a maximum charge voltage. So it's saying, this is the highest I want to be charged up to. It's sending it a maximum charge current, and it's sending it a maximum discharge current. And so the inverter is not going to go over those values. It's also sending its actual voltage and its actual instantaneous current and temperature and these other values as well. And so if you click on here and you see this and all these values are blank, that means that the BMS isn't communicating with the inverter. And that means that it's either a problem with the battery or a problem with your cabling. You won't have this menu option if you don't have managed battery, lithium batteries enabled on the inverter. So you've got your setting, at least the basic setting, correct if you have this menu available to you. If you're using open loop batteries, you won't see that Li BMS option there. And then if you click in the middle, you'll see this general inverter information here. The other thing, just to mention, that's come up a couple of times, is in the middle here, it says on. And there's a switch to the left-hand side of the inverter next to the PV isolation dial. And you need to have it on for it to work. And that's actually quite easy to miss, because the screen will be available even when it's off. So it's just an easy one to get wrong. I don't think I need to be in here for the rest of these slides, so bear with me a moment. I'm just going to go back to the normal presentation because I think it displays a bit larger. Yep. Okay. So once we've checked all of that stuff, we're going to be looking at our actual settings. And you might want to do this. Some of this you'll need to do beforehand so that the BMS comes up like I just described. Battery settings is the first one that we are interested in. And so I've got basic settings first. So, okay, basic settings. This is pretty straightforward. You're just going to set up the time and the date. Once you've got it connected to the internet, if you've got time sync on, then it's going to get its time and date from the internet anyway. But it's a good idea just to set that all up. There's this lockout all changes button. When you've finished commissioning it, maybe you want to turn that on. I don't advise having it on before you've commissioned it, because it means it's going to stop you making changes sort of every 10 seconds. And you're going to have to put in this password, which is 777. And that's quite annoying. But if you've got a customer who you think is going to fiddle with things, you might want to engage this at the end. Nick, yes, we will set up, we will talk about how to set up an unmanaged lithium battery a bit later on. There's no USB LAN dongle available yet. I believe there is one coming, but it's not available yet. So that's what you need to do in basic settings. And then we've got battery settings. So if you're doing managed batteries, you're going to set it to lithium, and you're going to set it to activate battery, and you want to disable the float charge. Battery capacity, you're going to set according to the amp hour capacity of your batteries. So say you're using Discover rack mounts, you've got 4 of them, you're going to put 400 amp hours. But because it's managed, it doesn't actually really matter, because the battery is calculating the state of charge instead of the inverter. And then you've got max charge and max discharge. So this is a global override, which is going to set what the maximum DC current in and out of the battery will be for the system. If the CAN bus requests a lower maximum charge or discharge, then the inverter will use the lower value. But if you set a lower value here than what the CAN bus ever asks for, then it will use that. So it will default to whichever value is lower. If you set the max charge as, say, 150 amps, but the CAN bus only ever says 100 amps, the inverter will only ever charge at 100 amps. When you've finished making changes, you need to tick this box at the bottom right-hand corner, and you have to do that for each page. Otherwise, it won't save your settings. After we've done that page, we're going to go into the next battery settings page by pressing the down arrow. And this is where you're going to set up your disconnection and charge rate settings for the grid or for the generator. So what we're setting here, if we just assume that we're on grid for now, we're just interested in this right-hand column here, which is grid charge and grid signal. And so what this is saying is that if the battery gets below 30%, then it's going to charge from the grid. And it's going to charge all the way up to the top. And it's going to do it at a rate of 40 amps. And that's a DC value. But it will only do that if you have grid charge ticked here. Grid signal isn't really used, so don't worry about that. On the left-hand side here, this is basically the same logic, but that's for a generator on the generator port. So if it gets below this value, then it's going to charge from the generator port at that rate, as long as you've enabled it in this box here, in the gen charge box. And if you're using the 2-wire generator start-stop, then you've got to tick gen signal as well. And we'll cover that in the gen section. Third page is only for unmanaged batteries. So if we go back to this page, if we're doing unmanaged lithium batteries, then we're going to select use battery voltage, and everything else will be the same here. And then when we get to this page, we're then going to put in, excuse me, the manufacturer's specifications. So for Discover, those are in the manual, along with the managed settings as well. And PowerPlus have settings on their website as well. I'll just quickly share my screen for that. So if you, this is going to be on our tech portal as well, but if you just Google PowerPlus Deye, then they've got this great document. And that's going to give you the settings that you need to put. There's not a huge amount of them. The same for Helios and Discover Rack Mount. There's settings just like those that are available in the manual. But I'd recommend using managed when you can. And the same for Pylontech. I don't think there's an unmanaged integration guide available for that. So for Pylontech, it's going to be exactly the same process as for Discover. And then this last setting is going to be your shutdown and restart values, the same as you would have with Victron or Selectronic. Basically, what this is deciding is at what point will the inverter stop producing any AC. So it's gone past its charge from the generator or charge from the grid state of charge value. They haven't started for whatever reason. And so it's getting down into emergency shutdown. So 10% is good value. Maybe you'd have it slightly higher. And the warning, so shutdown is when it's going to actually switch off. Low battery is when it's going to start having an alarm. And then restart is when it's going to start producing AC power again. It will still charge the batteries from the PV while it's shut down, but it's just not going to provide any power. So usually it's a good idea to have the restart value set up reasonably high so the batteries don't sort of flip in and out between states, and that they get a reasonable charge before the system starts again. If you're using unmanaged batteries, this will be exactly the same, but you're going to have voltage values instead of state of charge values for this page. And again, don't forget to click the bottom right-hand corner to save your settings. For the grid settings, it's just going to be Australia A, B, or C, depending on what your DNSP specifies. I don't recommend that you go through and mess with the grid settings. And then if you're doing three-phase or split phase, you're going to specify that here as well. After you've done that, you're going to go to the advanced function menu. This is not particularly difficult either. There's not too much to remember, but it is important that one of the big gotchas that we see is that DRM comes as on as standard. And so unless you've got a DRM device, if you're in Queensland, you might have one of these, then the inverter is just not going to work until you turn DRM off. So get in here, turn that off. And then if you're doing managed batteries, you also need to turn BMS error stop off, which is here in the bottom left-hand corner. You see BMS error stop. And what that does is that if it stops receiving commands from the battery, it ceases functioning instead of just continuing on with whatever the last command is. I don't know why you'd actually really have this as an option, but you need to turn that on. The rest of these you can leave as standard, which is off. The second page of advanced function, up the top you've got here parallel master slave, and then you've got phases A, B, and C. If you're doing single phase, you just got a single inverter, it is slave, not master. And that's a bit counterintuitive, but that's how it comes as standard, as slave. And then if you're doing parallel or three-phase, you're going to click parallel, and then one of them you're going to designate as the master and set that so phase A, and then the subsequent one is going to be a slave and B, and the third one is going to be a slave and C. And you'll set each one with a different Modbus address as well. If you're using an external meter, you're going to set that up here as well. So if you're using the CT that comes with it, then you don't need to do anything here. If you are using an external meter, you need to put on external meter for CT, and then you need to select Estron 1P if you're using the Estron SDM 120, which we sell. And if you're using the three-phase meter, you need to select, is it Estron 3? It is the Estron three-phase meter we sell now, isn't it?
Yeah, Estron 330.
It is? Yeah, so it's pretty straightforward. If you've got a Chint meter, you select Chint. If you've got an Estron, you select Estron. So it's pretty straightforward. There are some other meter options for monitoring AC coupled solar that if we have time, we'll go into, but we're running out of time very quick. You don't really need to worry about this page, ATS. That's not going to, I haven't had anybody need to use that so far, so you can leave that one. So this system work mode, I'm sorry it's taken me an hour to get to this section. This is probably the most difficult part of setting it up. This is the most confusing part of it, because just the way that it's described is not the same sort of lingo that Selectronic and Victron use. And, you know, you and I still get kind of confused about it sometimes.
Yeah.
But I'll do my best to explain it in a way that makes sense to people. We've got three options here on the left-hand side. There's really two options. It's selling first or zero export. And it's either zero export to load or zero export to CT. The difference between the zero export to load and zero export to CT is if you had the CT right at the inverter, then zero export to CT and zero export to load would be the same, which means it's only going to supply power, supplementary power to the load terminal, and it won't try and push any electricity out of the input port to support loads on that side. But if you put the CT at the main switchboard and you've got a load in between the main switchboard and the inverter, then it will attempt to support those loads by exporting power out of its input terminals and then on, but not enough to push current out into the grid. The thing that's confusing about this is that it's either trying to keep the inverter itself current at zero and have nothing going out of the inverter, or it's trying to keep the meter or the CT at zero. It's probably the best way to describe that. The thing that's confusing about it is it's called zero export, but it then has this option next to it called solar cell. So whilst it's set up as zero export, it can sell excess solar to the grid if you have solar cell ticked here. It's confusing if you're used to, say, a Fronius inverter where zero export means zero export, because there's only one thing available, which is just the PV input. But in this scenario, we have two things available, which is our PV and our battery. And so if you're on either a zero export to load or zero export to CT, and you have solar cell enabled, what that means is that it will use the solar to charge the batteries and to run loads. And then if it has any extra, because either the batteries are full or it's exceeding the charge current into the batteries, then it will export that extra to the grid. If you don't have it enabled, then it will only ever produce enough solar from what is available to charge the batteries at the highest rate that it can and offset any AC loads that it can. If you have it on selling first, then it means that not only is the solar power available to export to the grid, but the battery power is available to export to the grid. And how that is managed will be on the next page. Max solar power is just a value you can use to curtail the maximum output of the solar array. Max cell power is the maximum amount of PV array that would ever be sent out to the grid, or battery power. Zero export power is just an offset. So say you've got it set to zero export to CT or meter, and say you're an industrial customer, commercial customer, and you get fined for exporting even a little bit out to the grid, then you might set zero export to 20 watts or 100 watts or something, so that you're always pulling 20 watts to make sure that you're never actually exporting. So for most residential applications, that's not going to be a problem. And then we've got down here the max cell power. Sorry, we covered that already, but that's also if you haven't done CSIP and you want to curtail the amount of export from the inverter to the grid, then you would set that up here. You'd put that to the 500s. Lachlan. So we want zero export to load and solar cell ticked on a normal residential battery solar setup. No, close, but I think you'd have it zero export to CT. I'm just going to share my screen and I'm going to draw you a little diagram. if I can. Yep. Okey-doke. So just wait for this to come up. Okay. So here's my inverter, and you know, let's have the grid over here. Draw a little symbol for the grid. Look at my inverter, and then look at my connection, my AC connection to the inverter. And so I got in and out of the inverter. Now, I can have a load here, and I can have a load there. And then I'm going to have my meter or my CT at my main switchboard with a little bit of comms going back to it. And so if I had it set to zero export to load, because this is the load terminal, and then we have like the grid terminal is the input terminal. So if it was zero export to load, it would only support the loads on the right-hand side here. It wouldn't try and offset the loads on the input side. So any loads you had on this side would be running off the grid. But if you have it set to zero export to CT, then if you have a CT or a meter in the main switchboard and a load in between there and the inverter, then it will support the loads on the load side and on the grid side, which is probably for most load shifting hybrid residential city type applications is probably what you're going to do, because you might not even have this one connected at all. If the power hardly ever goes out, then you might not bother running the cable back. You're just going to have it all on this side, depending on what the customer wants. Gary, I always set these to zero export to CT and untook the 2 cell boxes. Yeah, so that just means that you'll never feed in any solar to the grid, any excess, which is fine. So I'll just bring back up my slides. We're going to go over, I'm afraid, sorry everybody, over time. And then we've got energy pattern, and that's just the PV power priority, whether it's going to go to the battery first or to the load. And then peak shaving is if you want to limit the amount of power that you're going to pull from the grid. So we've selected zero export to load, zero export to CT, one of those two, for instance. And then we're going to go on to this next page, which is time of use. You have to tick time of use, and then you have these columns and rows here. So each of these rows is a segment of time. And so if we just take the first section, then that's between 1 a.m. and 5 a.m. And what we're basically saying here is that in this period of time, the inverter is going to try and keep the battery at, and this particular screenshot is from an unmanaged system, 49 volts. If we ticked grid charge here, then it would be allowed to charge the batteries from the grid in this time section. And it would only charge them if the voltage got below 49. And if the voltage got below 49, it would charge them back up to 49, and it wouldn't charge them over that. And it would do it, according to this column here, power, it would do it at 5,000 watts. So if you have a plan, for instance, when you are getting free power between 11 and 3 or whatever it is that's available now, then you might set that to whatever your peak charge voltage is, or 100% with managed batteries. so that just during that time period of day, it just uses the grid and charges the batteries all the way up because the power is free. Or you might have a lower tariff at night, or a higher tariff first thing in the morning. So you might have an evening setting where you don't let the batteries go too low, and you allow it to charge from the grid. If you never want the system to charge from the grid, then you just have all of these unticked.
Is the solar still going to charge it if the battery percentage reach to the set percentage I set it up there?
Yes. So this is just managing how it uses the grid. If solar is available, it will just charge the batteries all the way up to the top. This is only what it will do in relation to the grid or the generator, depending if you have them enabled for that period of time. Where it gets a bit more complicated is if we go back to this page here, if we have it on selling first, then we have to take into account the battery power being sold to the grid as well. So that means that if I've got on selling first, if the battery voltage gets below 49, it's going to, and I've got, so say it's after 9 o'clock, I've got grid charge enabled. If it gets below the set voltage, it's going to charge back up. If it gets above that, it's going to sell the battery power to the grid until it gets down to that set voltage. So obviously, if all these voltages were set the same or percentages were set the same, then it would just be the excess solar that goes into the grid, and the battery would never be in a position to be higher. But if it ticks over to a new time slot, then suddenly it went from 100% down to 50%. If it's 100% state of charge, it's going to export power to the grid until it gets down to that set point. And it's going to do it at the rate set in the power section here. Similar to scheduled charge with electron. I guess it's a little bit similar to that, but it's not 100% the same. It's actually maybe a bit more flexible. So what this is really good for is that, so again, Glowbird have this, I'm sure there's others, but this is the one that I know of, this plan where between 11 and 2 or 3, power is free. And then between 6 and 8, you get paid for not using anything, and you get a 15-cent feed-in tariff for feeding into the grid. So you would set it to 100% between 11 and 3 or 2, and get your charge all the way up, your batteries all the way up to full for free during that period. And then between 6 and 8, you would set it at, depending on the size of your battery bank, you might set it down to like 40% or something, because you're going to need the rest of that capacity of the battery to get you through to tomorrow morning before the sun starts charging your batteries up. So you're just going to export that battery power between 6 and 8 when you've got that nice high feed-in tariff. And then after 8 o'clock, you're gonna just put it back to no grid charge, so that it doesn't charge the batteries back up again from the grid. I realize it's quite confusing, but it means it's designed for taking advantage of these types of scheduled feed-in tariffs and export tariffs. So yeah, that's an example of it with percentages rather than voltages. And then for some reason on this page here, I guess because it must be different sort of plans available in other countries, you can turn it off on certain days. If you're doing off-grid, then basically you're not going to use time of use, because when you're off-grid, if the generator's on, usually that just means you're going to use the generator. You're not going to have the generator on but not wanting to be used as power. So you're just going to have time of use off. So the main gotchas with commissioning it is DRM. Make sure you switch that off when you first turn it on. BMS error stop needs to be on. Take into account the inverter. Whenever you make a change, it takes a little bit of time to start. You've got the system lockout password. You've got to get your head around time of use. If you're doing it for the first time, give us a call and we'll help you with it. If you switch the generator to the grid input, well, I'll go over this in a moment with the generator port. Now, there's some questions about overcharging of batteries. So on some of the Deye firmwares, David said very few failures a day. Yeah, I don't think I've had it. Oh, you have one, didn't you? You had one inverter, one Deye or a NOARC with a faulty screen.
Yeah.
Right? Yeah, that's the only one I can think of. We haven't had any. So what somebody's asked for previously about the overcharging, this is the only thing that I've seen, which is of them overshooting the voltage sometimes. The way that the different battery manufacturers control the inverter is by giving a target voltage or a target charge current. And different inverter manufacturers seem to interpret the data slightly differently. And so what we did see happening with Discover batteries is that they were throttling the charge back by presenting a high charge voltage, and then when it gets close to 100%, giving it a lower charge voltage, which would make the inverter stop charging, which works really well for Victron, because Victron is very voltage based in terms of its charge algorithm. But the Deye inverters were getting a bit confused by that. And so Discover have brought out a new BMS profile, which instead of trying to manipulate the inverter by changing the charge set voltage, it's just reducing the current as it gets towards the top of the charge cycle. So effectively doing the inverter's job for it, which is throttling off its charge as it approaches the set voltage. It's what the inverter should do anyway, but it's doing it for it. So I'll share my screen again, and I will show you how that works with the Discover system. Give me a moment. Stacking A1 inverters is very similar to wall mount. David again. Yes, so the stacking, we're sort of focusing on the wall mount style Deye inverters, but the interface and the menus are basically the same for the new stacking batteries. So there's a Deye stacking battery, 48 volts. It's very similar to a SIG. You stack the batteries up and then you put the inverter on top, and it looks very different to the wall mount ones, but it's just my understanding of it is it's just the sort of the chassis is a different shape, but the components inside is exactly the same. And so that's a pretty compelling new product. We did a webinar on it the other day, and the commissioning process is the same. So let's just get this happening. Okay, just check that everybody can see this. So if you're doing a Discover system, you're either going to be taking the CAN bus directly from the Helios battery, or you're going to be using a link to. In either way, you want to set up the CAN bus protocol. And so the standard that the Helios batteries were coming out with was dynamic voltage. And that works very well for Victron. But if you are using a Deye inverter, we recommend that you go to dynamic current.
Oh, it's not showing up.
Ah, it's not showing up.
So you probably want to share it on the screen.
Yeah, I'll just share the whole screen. Sorry about that. Okay, Here we are. So I'll just take you through that again. So this will be very similar on the Helios. There'll be a CAN bus menu that looks a lot like this. You just click on the settings, and on a Helios, it will come standard as dynamic voltage, and you just want to change it to dynamic current if you're using a Deye or a NOARC. If you're using a Link 2, then there are these other options here like Deye, but we recommend actually using just the LV BMS dynamic current rather than the specific Deye one at the moment, because it's the more up-to-date one. It's not necessarily a fault of Discover or of Deye. I think it's just different styles of charge control and then just optimizing those. I haven't seen any of them have got worryingly over voltage, but sometimes the BMSs are quite trigger happy, and they basically see any voltage that is above what they've asked for as a potential problem, so they'll switch off, even though they're well below the danger area. They'll switch off. And get back to here. Stop sharing the screen. Okay, so forgive me as I flick through some of these slides. Gen port use. So for the generator, if you're off-grid, a lot of this stuff isn't going to apply. You're not going to need to use time of use. So it's just going to assume that any available AC source is fair game. There's a few options for the generator. So the inverter has basically 3 AC connections on it. It's got the AC input, and it's got the load, which is AC out, if you're speaking in Victron language. And then it's got a third port, which is the gen port. This is just another contactor-controlled connection to the AC bus. And so it can be used for a generator, or it can be used for an AC-coupled inverter if you're off-grid or on-grid. And it can be used for smart loads and things as well. If you're off-grid, you don't have to use the generator port for the generator. You can use the grid port for the generator. And if you do that, in this menu here, you just tick here, gen connected to grid input. I'm not sure why you would need to do that really. I'm not sure what the practical reason for that is. It might be that you want to use the generator port as a smart load, in which case you'd enable smart load output on the left-hand side here. The generator can be automatically triggered with a dry contact that the inverter has. And we set that up here. So it's a normally open relay, and that's just for a 2-wire auto start for the generator. And that will start the generator once it gets to the set threshold that we saw at the beginning. And I'll see if I've got a slide for that. No, I don't. So when we set up the generator charge and the grid charge, there was an option for generator signal. You need to tick that in order for it to use this dry contact. And so when it gets below the threshold that you set in that menu, let's go back to that, shall we? I think this is important. Then it's going to trigger the generator to turn on. So when you're commissioning that, I suggest that you set it. Here we are. So it's in this setting here. You want to have generator charge ticked, and you want to have gen signal ticked. And that means that the dry contact will turn on when it gets below 30%, and it will charge at this rate. You can test it by clicking this button here, Gen Force, and then obviously you have to click the tick down the bottom here. And then I suggest that you manipulate the start voltage according to what the state of charge of the battery actually is to check that that is working as well. Make sure all of that is working. Other than that, it's pretty straightforward, and it's just going to charge the batteries up to 100%, unless you've got the time of use set up otherwise. So that's most of it. Now, I think this is for, sorry we've gone so far over time, but for Jeff's first webinar, we thought it might be a good idea if you had some curly questions to ask me.
Right. So yeah. Oh, okay. So say I got everything wired up. I got my panels wired up on a day, and I got my batteries. Let's say I'm using Helios, and I got 3.
Yep.
I have set up every settings in the battery settings, but how do I know? Basically, you have covered in the webinar, but I think it's quite a common issue. How do I know my battery is connected properly to the day?
So you're going to go to that first menu we saw with the 4 icons, and you're going to go down to the bottom left-hand corner. Let's bring this up. And you're going to click on the battery icon, and then it's going to say LV BMS in the bottom right-hand corner.
No, but it's not showing up there.
Okay.
What's wrong?
So if it doesn't say LV BMS,
LIBMS.
what did I say?
LV.
If it's not showing, that means that you haven't got the battery setting correct. It means you've got it on use battery voltage or use battery percentage or no battery. It needs to be on lithium. So you might have done it but forgotten to press the little tick button in the bottom right-hand corner. So once that's on, then you will definitely get this LIBMS in the bottom right-hand corner here.
Right, but I got that. I think, yeah, I've changed the settings to lithium.
Yeah.
But now, and I can see the LIBMS, but there's no reading, and I'm using the Helios battery. What can be wrong?
Okay, so then we click on LIBMS and we see this box we've got in the middle here. And if the battery is communicating with the inverter, all these values will be populated like you can see here. If they're all blank, then it means it's not getting the data from the battery. So if it was, say, Pylontech, you would check that you had the cable plugged into the ACAN port and not into one of the others. Check the battery's on. If it's Discover, if it's a Discover Helios, the main sort of 2 things that we see is that you've got to be connected to COM port number 2 for the CAN bus output from the battery. You won't get CAN bus that the inverter can use out of COMS 3 or COMS 4. And then if you have 3 Helios batteries, then you're going to connect those together in parallel in terms of the comms with a standard RJ45 cable between COM 3 and 4. You can use either of them to connect them together, but it comes with a little N terminator, which I've spent half of my day sending to people today. You have to put that in the first or the last battery, which has a spare COM 3 or COM 4 port that you're not using. You have to put that in for the BMS to fire up. If you haven't got it in, it's not going to turn on. So that comes with the battery in the same cable that the little black cable comes in. If you lose it, we've got a bag of them here, a couple of bags of them now, I think. So we can send you some more. But if you've got 3 batteries, you should have at least 1. Keep them so in case you lose them for the next job. That's a good idea to have spares.
Even with 1 battery?
Even with 1 battery, you need to have it.
Right.
If you're using a Link 2, so you can use the Link 2 to communicate with the cloud, and you can use the CAN bus out of the Link 2 instead of the CAN bus out of the Helios if you want to. Then the Link 2 actually has a terminator built into it, so you don't have to have the N terminator if you have the Link 2. But there's no harm in having multiples. You can't use a Victron end terminator because the pins are different. I think you can use a Schneider one. How do I get that load icon on the main screen? That's your area of expertise, isn't it?
Yeah, load icon. Oh yeah, yeah. It's yeah. You need to update the firmware. Yeah. Get us your serial number, and then or just share your site to us, and then we'll update it for you.
You can update the firmware through the app. But I think you have to have the file. And I've been trying to get the files out of Deye so I can make them available, but you have to be very careful to get the right ones. And I haven't had a good chance of figuring out how to make sure I give people the right ones at the moment. So we'll have to do it on a case-by-case basis. But I think all the new inverters have that firmware. Okay, the site is brand new and not on the net yet. Okay. If you've got a, you won't see it if you have it on always selling, I don't think. It's only on zero export to CT or zero export to load that you'll see that, I think.
Right. All right, I'll continue my question.
Yeah.
Right. Okay. Now I've checked everything, and then I got batteries. I got all the voltage and current readings, and I got the BMS readings.
Yeah.
But I'm in Victoria. The system just don't work. I'm pretty sure my panel is linked. I'm pretty sure my battery is linked. I'm pretty sure my wiring is right, but the system is just not doing anything.
Did you turn it on?
I turn it on.
I'm
pretty sure. I can see everything on the screen.
There's a button on the right. So it says on in the little green thing. And then you've got to, have you turned DRM off?
Oh, I haven't. Yeah, right. Yeah. All right, so I'll untick the DRM. What about the time of use? Like, because inverter is still not working. Do I have to turn the time of use on as well?
Yeah, you do if you're on grid.
Oh, okay.
Yeah.
Right. Okay. AC couple.
AC coupled. So Dina says, can you talk about AC coupled on a hybrid system? Export limit of 1.5. This was going to be your other question, wasn't it?
Yeah.
So AC coupled on a hybrid system. So maybe if we go back to my crude diagram, normally I have really nice little symbols, but for some reason the library is not loading, which is just typical of a webinar. Where are we? Let's share the whole screen. So let's go back to here. Okay, so we're AC coupled. We've got our inverter in the middle here. Let's label that to avoid some confusion. Maybe we should call it Deye, a Deye inverter. And we've got the grid over here. And then we've got an AC coupled inverter that we want to include. And so let's put that here. And let's have our AC bus. Now, I've got two options. I can put the AC coupled inverter on the load side, or I can put it on the grid side. Let's get rid of that. Now, if I put it on the grid side, then it's just going to act like a normal grid tie inverter, and it's going to be governed by its own internal rules as to how it exports to the grid. But when the grid goes down, it's just going to go down. It's not going to support the system in the event of a blackout because it's not on the backup circuit. So that's pretty straightforward. It's not really a lot you need to do with the inverter in that scenario, unless you sort of got some sort of complicated export limitation you need to do because the total power of the two of them is more than what you're allowed to export. But that's the common scenario that we get asked about is when the AC coupled inverter, let's call it Fronius, is on the load side. And so in this scenario, when the grid is up, we're connected to the grid. The Deye inverter is synchronized to the grid. so it can't frequency throttle. So that means that the Fronius is just going to do its job of just putting out as much power as it can, and it's going to go into the Deye, and the Deye is going to use that to charge the batteries, and then any excess is just going to keep flowing through the AC bus out to the grid. If there's no export limitations or anything like that to worry about, then that's pretty straightforward. When the grid goes down, the Deye is then in control of the AC waveform, and it can use frequency shifting to ramp the Fronius up and down and prevent the batteries from being overcharged and control it. And you don't need any comms between the two of them in order to do that. The thing that's slightly more difficult is if you've got some export control. So say I've got a 5 kilowatt limit for my export, right? Let's make this a bit more legible. So I've got 5 kilowatts of export limitation. Now, if I had a 5 kilowatt Fronius, then it would be reasonably straightforward. You can tell the inverter that the maximum export, you tell the Deye that the maximum export is 5. And you've got a meter here, and it can see what's going out. And if it doesn't matter that it's not producing it itself, if it sees it being more than 5 or being on 5, it's not going to produce anything so that it doesn't exceed that. And so you don't need to do anything with the Fronius. If the Fronius, say, is a 10 kilowatt, then things get a bit more complicated. You're going to need to have a meter for the Fronius. And so, because the Fronius is going to need to know how much is going out to the grid, and you're going to have to set up export limitation on the Fronius. When you do that, you're going to have to tell it that if it loses communication with the meter, not to ramp down to 0. Because otherwise, when the grid goes down, this meter is going to switch off. Unless you had it, I guess you could have the AC wired to the backup circuit, but normally you wouldn't. This meter is just going to disappear. In which case, what the Fronius would do is that it would export limit itself to 5 because it can't see the meter, so it's just only going to put out 5. Whereas when the meter is there, it will put out more than 5 if it can see that the meter is 5 or below. The issue with that, obviously, is that when you're in off-grid mode, you're then limited to 5 kilowatts, even though you've got a 10 kilowatt Fronius inverter. And it also makes things a little bit more complicated with the 2 meters with the Deye, with the export control as well. Hopefully that answers your question. It can be done, but it's just when you have export limitations and you've got a larger inverter, it gets tricky. So this would only be if it's a greenfield installation, you would either have the solar array on the Deye and not have an AC coupled inverter, or you would use the Deye like you would a Victron and just have the whole array on the AC coupled inverter if you wanted to do that for some reason. Or you would set it up so that the AC coupled inverter, if you really wanted to have solar on both, you'd set it up so that AC coupled inverter wasn't any larger than the export limitation. If you are doing a retrofit, then that's when you might run into some of these issues when you have a larger inverter. And in that scenario, perhaps you wouldn't add extra solar to the Deye. You can, but it's just going to make setting it up more complicated. And you just use the Deye as a battery inverter. You can also put a meter on the Deye to monitor the AC coupled solar as well. And you can put it on the generator port so that it can turn that off without switching off the rest of the loads as well. There was a question here. In off-grid, should we avoid AC coupled solar to avoid backfeed into the generator? There's a few different ways you can go about that. One good way of doing it is just to set the frequency of the generator to 52 or 53, so that as soon as the generator starts up and the day synchronizes with it, that just automatically shuts the AC coupled inverter down. The other thing you can do is use the input pins on the Fronius inverter, and you have a relay attached to the input, the generator input in an off-grid system. So as soon as there's AC on the generator input, before the inverter is even synchronized with it, that relay is going to close, and you key that to the inputs on the Fronius, but that will only ramp them down to like 100 watts. It won't ramp them down to 0, in my experience. So yeah, you don't necessarily need to avoid it. You just need to have it as part of your design process. What about AC coupled into the generator port? Yeah, so you can AC couple into the generator port, and that gives you a little bit more control over it. You'll be able to turn it on and off without turning the loads on and off, which is a good idea in some scenarios. Okay, we've gone well over time. Any other questions before we go? No, okay, I'll be sharing the slides for what that's worth, and this will be going up on YouTube. We're also going to be doing a series of short videos of us just explaining how to do a small section, so that when you're on site and you just want to know how to do time of use, for instance, we'll have a short video just on time of use. It'll be like 2 minutes long or something like that, so you don't have to go all the way through a long-winded webinar like this one to find what you're after. So those resources will be coming out over the next couple of months. There's some available already, which will be going up on YouTube in the next couple of days. Yeah, if you've got any questions, just give us a call, send us an email, and thanks for coming along.